Okay, so hello and welcome to my presentation on fire weather drivers of severity and spread, learning from past fire patterns to inform future wildfire decision making. So this research and this presentation is part of a joint effort with Grand Canyon National Park and Northern Arizona University. Next slide. Oh, there we go. All right, so it is well understood that fire is a critical natural disturbance and ecological process in the southwestern United States. However, as we've heard again and again by now, ponderosa pine and dry mixed conifer forest have been experiencing increases in forest density and fire hazard throughout much of the western United States, partially due to changes in land and fire management. And increasingly, large and severe wildfires have impacted these dry forests. So fires that contain these large patches of high severity fire have the potential to impact multiple natural, cultural, and social values across our landscapes. So in response to changing climate and changing fire regimes, Grand Canyon National Park was looking to expand upon previous research on weather and climate effects on fire in the park and increase the pace and scale of forest restoration using fire within park boundaries by addressing this National Park Service Fire Management Leadership Board priority area of implementing research that assists in removing stumbling blocks and hurdles for implementing fuels treatments and managing wildfires for resource objectives. So Grand Canyon has quite a substantial fire organization already that typically manages numerous prescribed and wildfires annually, providing them considerable depth of resources and experience to manage these large and complex fires at the park. So each year within the park's boundaries, managers can decide whether or where to use prescribed fire or to allow these lightning ignited fires to burn for multiple objectives. When making these decisions, managers have to consider a large multitude of factors. So vegetation, topography, have previous fires burned in the area, current field conditions, etc. So these are all important drivers of expected fire conditions. And if they have the right resources available to actually manage fires at the park and on the landscape. However, we all know wildfires are also affected by the dynamic weather and short-term climate conditions in the Southwest. So air temperature, moisture conditions, wind, these are all known to have strong effects on fire behavior, fire severity, and fire spread at these different various scales, influencing conditions on the fire line. So within Grand Canyon's forest ecosystems, considering weather and climate, we asked, how can we better understand the weather and climate conditions under which fire behavior becomes more extreme, or alternatively, can help us actually achieve restoration objectives? So the real challenge is to help predict if expected fire behavior will surpass thresholds of severity and spread that threaten ecological and social values of the park, while simultaneously identifying those conditions conducive to actually using fire and potentially moving stands and landscape conditions towards desired conditions or desired fire regimes. Specifically, this research aimed to model and provide predictions of fire severity and spread during variable weather conditions under which fire typically has burned at Grand Canyon, and then provide those climate thresholds that affect fire severity and spread to inform which fires may be beneficial or incompatible with multiple resource objectives. So in doing so, we also aim to develop tools and products for Grand Canyon to assist fire management planning and implementation of this research so that Grand Canyon can quickly assess risks and identify conditions that are likely to affect fire behavior outcomes. So, of course, our study area is located on both the north and south rims of Grand Canyon National Park. That's in northern Arizona on the Kaibab Plateau. And these red polygons you see here indicate the location of the fires that we specifically analyzed for this study. Fortunately, Grand Canyon had 19 large multi-day fires between about 2000 and 2018 that were mostly managed for resource objectives and had that available daily fire perimeter data for us to analyze. So using all 19 of these fires, that burned about 99,000 acres, and there were a total of 488 consecutive progression days across all of the fires. So these are the fire progression maps of those daily area burned. This was provided by the park and mapped for these 19 fires. We did remove some perimeters that did not have progression data from a previous consecutive day, since we could not really match the daily climate data to the fire area across multiple perimeter days. Okay, so then using vegetation data, also from Grand Canyon, we limited the analysis to areas burned within mapped ponderosa pine and mixed conifer forests only. Although there were some multi-day fires or area burned that occurred in other forest types, specifically pinyon juniper and spruce fir, the data we had in these ecosystems was extremely limited. So we just ended up not pursuing models in these other vegetation types. Okay, so fire severity data was derived for each fire using a modified continuous relativized difference normalized burn ratio. So yes, there's an asterisk there, and I will get back to what that means in a minute. But first, just to kind of go through the methods here. Basically, this RDMBR looks at the change between the pre-fire and the post-fire imagery while taking into account that pre-fire vegetation cover. So this provides a more stable definition of severity across space and time and can be used to more easily draw comparisons between these different fires. So for this analysis, we obtained the severity data using the Google Earth Engine platform, using code developed by Sean Parks et al. 2018. And so this code can take the mean cover value for all the Landsat pixels at any one point over a date range of 1 year pre to 1 year post-fire to produce the resulting fire severity each pixel. And we use this method because although Grand Canyon does have field validated fire severity for some of its fires, we really wanted to be able to increase our sample size for those fires that didn't have that data and use more fires. So to keep our analysis consistent across the project. So next, in order to obtain these thresholds for our severity classes from the Google Earth Engine data, we used 665 composite burn index plots that were measured at Grand Canyon on these fires in our analysis. So we regressed those values against the RDMBR to find the corresponding severity classifications. So plots with CBI values greater or equal to 2.25, that represents high severity fire, which in this case corresponds to an RDMBR value of 488 or greater. And now we did a slight adjustment of these values so that our unburned was equal to 0 for the sake of some of our presentation materials. So getting back to that asterisk, unfortunately, after wrapping up this analysis and report, we found out that the Google Earth Engine code we used to obtain our fire severity had an unfortunate error where the square root transformation in the equation's denominator was carried out twice. So essentially, instead of giving us the square root of the pre-fire NVR, we were getting the fourth root. And this did alter the values of the RDMBR measure. So for the sake of this report and presentation, I did do a really quick comparison of this data a week ago to see, or using the correct or accepted RDMBR measure. So first, the corrected RDMBR does have a high severity threshold of 682 and higher versus our 488 for the modified RDMBR. Interestingly, however, when I ran a comparison between the two data sets and the Grand Canyon CBI data, this modified or incorrect RDMBR equation actually resulted in a slightly better fit to the CBI field data than the correct RDMBR equation. Notice also in this pixel classification matrix I pulled up here, between the modified and corrected RDMBR, that the modified RDMBR turned out to be a more conservative measure. So when the corrected RDMBR classifies a pixel as moderate, the modified RDMBR will classify that pixel as moderate or low severity, but it never classified it as high severity. So it's probably best that we're potentially underestimating burn severity instead of seeing how much higher severity than expected. So we're not burning down the forest at Grand Canyon. So interesting results. We definitely intend to do some reanalysis with the accepted RDMBR measure in the next couple of months. But looking at these comparisons here, I think our work is still valid, and my gut feeling is we're not going to see huge changes in our models, but we'll see how that shakes out soon. So with that in mind, moving forward with our modified RDMBR, these are the mapped results of the fire severity for the 19 fires analyzed. And we can see that a couple of the fires, specifically the Big Fire, Outlet, and Fuller Fire, have some very large areas of high severity fire. But overall, many of Grand Canyon's large fires have actually burned at fairly low severity, which is potentially unique for the region. The data for weather and climate was mainly downloaded from the Northwest Climate Toolbox, other than wind speed, that we obtained from the RAWS weather stations near Grand Canyon. And then all that data was mapped at a 4-kilometer spatial grid, representing the daily 24-hour average weather variability coinciding with the daily fire progressions. So after obtaining all of the underlying fire severity, vegetation, topography, and the climate data, we created a grid of points across each of the daily fire progressions. So this information was extracted at each data point, so that each point represents a burned pixel with a unique combination of observed fire weather and physical characteristics on that burning day. And then to analyze this data and create the models, we used a gradient boosting machine model. And so this is quite similar to random forest modeling. Gradient boosting builds a series of decision trees. However, instead of building each decision tree independently, gradient boosting sequentially builds trees, and at each iteration, it actually adds weight to the observations that are more difficult to classify and lowers the weights for those that are more easy to classify from the previous iteration. So the idea is to try and improve the results of the previous model at each iteration, focusing on those observations that were more far away from the truth in order to obtain a final, more accurate model. So the final models we built for each ponderosa pine and mixed conifer fire severity and spread are shown here, along with the cross-validated AUC. So this AUC, or area under the curve, is basically the measure of the ability of a classifier to distinguish between positive and negative classes. So in our case, whether or not our model correctly predicts a pixel has burned at high severity or not. And so the higher the AUC, the better the model is at correctly predicting whether or not fire severity will occur during certain weather conditions. So for example, our ponderosa pine fire severity model has an AUC of 0.72. So it's able to correctly predict the occurrence of high severity fire at least 72% of the time. So in the case of fire spread, since it's not a binary like high severity or not high severity, we use different percentiles of spread base. So specifically analyzing each model's ability to correctly predict large runs at various threshold settings. So greater than 50%, or 50th percentile rather, 75th, 80th, 90th percentile of area burned at Grand Canyon National Park on these fires. So here for the mixed conifer spread model, the AUC of 0.78 for a 75th percentile, so greater than 75th percentile fire spread day, means the model was able to accurately predict whether or not a fire was expected to grow larger than the 75th percentile on that day. So the climate, topography, and fire variables listed here are those that best help us predict fire severity or spread in each ecosystem without overfitting our model or providing redundant or extra information. So one thing we found in this process with the elevation, vapor pressure deficit, and wind were consistently important predictors in all of these models. Okay, so with this information and in consultation with Grand Canyon Fire staff, we created fire severity and spread prediction tables to give Grand Canyon simple and effective tools to identify the expected fire severity and spread associated with daily weather conditions, potentially when managing a wildland fire incident. So these tables use past wildfire conditions at the park to provide fire staff with a quick but comprehensive assessment of expected fire activity during changing daily weather conditions on a fire based on current and predicted weather conditions. So thereby determining potential of fire activity to help managers work within the unique climate and topography at Grand Canyon National Park. So as mentioned previously, elevation, wind, and VPD were consistently important predictors across all four models and are generally accessible to obtain during an incident and several days into the future for planning purposes. So because of this, we use the combination of these three components to capture the expected effects of weather on fire severity and spread in these two dominant forest types in Grand Canyon, ponderosa pine and mixed conifer forest. So a quick aside for those who might be unfamiliar with vapor pressure deficit or VPD. So VPD is the difference between the amount of moisture in the air and how much moisture the air could possibly hold when fully saturated. So if our VPD is a high value, then the air is holding minimal water vapor. So it's very dry. So under these conditions, basically the atmosphere becomes a giant 6-mile-high sponge, and the arid air will induce water to evaporate from the soil and fuels, typically making them more flammable. So these conditions are of course not rare in Southwest dry forests in the spring and summer during the typical fire season. Okay, so briefly, the idea to use these tables, after assessing your forecasted average daily weather conditions for wind and vapor pressure deficit, you would trace the values for wind on the left and VPD at the bottom to the box where these values intersect. So the value in the box, in the case for the fire severity table, contains that expected RDMBR value. But more importantly, the severity classification based on those thresholds, specifically for Grand Canyon. So for example, if the average daily wind speed was expected to be 6 miles per hour and the 24-hour average vapor pressure deficit was expected to be 2 kilopascals, we could expect our fire to burn with moderate severity, or basically at this threshold between low and high severity. We also added these histograms, you can see to the left and to the bottom of the figure. And we added these to help inform the user where this model has the greatest strength to make predictions based on past conditions during these fires at the park. So predictions in the boxes towards the middle of those histograms, where we're seeing a lot more data, are more reliable, while conditions at the edge of the data distribution in the tails, there's a lot less certainty there. Similarly, we developed these for fire spread. So these tables contain the approximate acres expected to burn given the weather conditions and elevation. Certainly, values in these boxes for expected severity and spread are approximations based on past fires under the selected weather conditions and are not to be assumed to represent exact point in time conditions on the ground during an actual fire incident. So we really recommend to the Grand Canyon that this tool is meant to be a future planning tool for advanced single or multi-day predicted trends in fire conditions, along with local knowledge and on-the-ground observation, or in conjunction with other risk tools. So these tables we created provide predictions of fire severity and spread during variable weather conditions under which fire typically burns in Grand Canyon, and provides those climatic thresholds that affect fire severity and spread. These models are not intended to represent exact conditions on the ground, nor forecast a worst case scenario of potential fire behavior. This data is actually based on the average conditions under which fire burns at Grand Canyon National Park. So instead, managers should really be using this resource when formulating a strategy before engaging in operations by identifying weather conditions that are likely to affect fire behavior outcomes as they have during past fires. So my forecast shows that from potentially day 1 to day 4 of a fire, the weather is trending towards windier, drier conditions. It seems to me that sometime between day 2 and 3, we will need to reevaluate the management strategy because we're starting to see transitions between severity and spread thresholds towards those higher values. Great, so here is the full series of the fire severity prediction tables that we created for Grand Canyon. We created these for ponderosa pine and mixed conifer forest at 8,000, 8,500, and 9,000 feet. And that's based on where these forest types exist in the data on the landscape and other tools that Grand Canyon uses when they're analyzing potential fire behavior. So something we noticed when looking at these side by side is that BPD seems to have maybe a slightly greater influence than wind in determining the predicted thresholds between low, moderate, and high severity fire. We also noticed that opportunities for moderate severity fire are actually quite limited in ponderosa pine forest, especially compared to these mixed conifer forest tables. While in mixed conifer forest, there was a larger margin for conditions that could result in this moderate severity fire, but low severity fire is definitely a lot less likely, especially as elevation increases. And of course, here are the tables for our fire spread data. Generally, across both ponderosa pine and mixed conifer, we found a discernible increase in expected area burn at a potential threshold when those average winds become greater than about 4 miles per hour, concurrent with moderate BPD. And we also noticed that whereas BPD may be the driving force for the severity thresholds, it seems that wind potentially has a slightly stronger influence on expected spread acres, which of course is not surprising because as winds increase, we would expect to see our fire spread quicker and more acres. All right, so I do want to make sure to mention some of the limitations in our modeling, especially in using these prediction tables. So I've said this a couple times, but really these tables are based on the effects that weather has on fire behavior, but does not directly account for the physical processes that influence fire on the ground. So fuel arrangement, fine scale topography, potentially prior management actions. And it's always possible that localized conditions could decrease or increase fire behavior on any given burning day. So the model and the tools are really intended to capture a longer term average of potential daily fire conditions and really should be limited. They're not really meant for extreme wildfire events. Second, weather conditions represent the daily average 20-foot wind speed, and the VPD conditions averaged across a 24-hour period. So they're not necessarily point-in-time observations. So these tables should not be used on an hour-by-hour basis and really may be more appropriate for advanced single or multi-day planning using predicted weather over a 24-hour period. And then finally, the unique topography and climate and management efforts at Grand Canyon National Park, their fire program, have really resulted in a fire regime where large, destructive, high-severity fires have been comparatively rare within the park's boundaries. So because of this unique landscape and the unique fire program at Grand Canyon, these models are specifically relevant to the park or potentially other restored landscapes and may have limited application in altered dry forest ecosystems across the Southwest. So of course, there's no one magical tool that captures everything that influences fire. And for this project, we are really focusing on that short-term climate weather piece of this puzzle and how that could help Grand Canyon. Okay, so using fire to meet resource objectives contains an inherent level of risk because we're dealing with a number of unknowns and uncertainty in what the immediate future will bring. But in many cases, it really is the most effective way to accomplish field treatment and landscape scale ecological restoration. So the fire severity and spread prediction tables and the models were created to characterize fire severity and spread associated with daily weather conditions at Grand Canyon National Park as a reference on what to expect when managing a wildland fire incident or a planned prescribed fire. So however, National Park Service policy generally directs land managers to maintain natural environments evolving through natural processes minimally influenced by human actions. So the maintenance of natural conditions, that's going to preclude mechanical forestry practices such as thinning or tree removal, and is overall seen as socially unacceptable to the public within park boundaries. So managing wildfires for resource benefit can achieve fuel reduction and typically a level of restoration that could point a landscape towards a desired future condition with relatively little upfront investment in time and money or direct influence. And on a managed fire, there's the potential for more leadership structure, resources, and support that would be available on a planned prescribed fire of the same acreage. So the research framework we discussed here provides important insight concerning the importance of fire weather factors in determining the potential fire severity and spread on the landscape. And these analyses also provide an important decision support tool to fire managers in the form of these fire severity and spread tables. So the fire severity and spread prediction tables were created to characterize fire severity and spread associated with daily weather conditions at Grand Canyon National Park as a reference on what to expect when managing a wildland fire incident or planned prescribed fire. And then finally, we did this research to have direct and immediate application to fire planning at Grand Canyon, but there is the potential to extend this framework and this research to the Southwest that's aimed at using fire to restore and conserve our forest ecosystems. Okay, so I'd really like to acknowledge my co-authors who helped me work on this, so Andy Thode and Jesse Young, for all of his help with the statistics. And then of course, we had a great relationship working with Grand Canyon. So Matt Emring, Christopher Marks, and Aaron Banwell, who started the project. And of course, thanks to Grand Canyon National Park and Northern Arizona University. Okay, so yeah, thanks for listening to my presentation. And yeah, I would love to know if you have any questions. But maybe before, if Matt is still on, he could tell us a little bit about how he actually plans to use this at Grand Canyon.
Yeah, Matt, let's see if I can unmute you.
Yeah.
I think we
How
can.
about now?
Yep, great.
Okay, well, that's good because I cut out for a little bit, but I am reestablished and
So we're lucky to have Matt calling.
Yeah. So here at Canyon, we're looking forward to using this. We've got all the information and in the process of disseminating it out to the field. You know, we're looking to
Whoops.
hello.
Matt, you're coming through a little choppy. I think we can all be patient and just let you forge ahead.
Hey guys, am
so,
I still on, or is that?
Yep, you're still on, and it's a little better now. So everybody else, Matt's calling in from the Grand Canyon out in the field.
Hey, testing.
Okay, we've got you for the moment. Let's try one more time.
I think there's delay.
Okay, I think Matt's connection might be a little bit too difficult to deal with. We'll give it, he may be able to and be slightly stronger signal in a little bit. So there have been a bunch of good questions that came in, and so we'll turn to those. The first one is from Serena that asks, is using the past as an indicator for future fires, considering climate change and drastically changing fire conditions, especially within the last 3 to 5 years of fires, how useful is that, or do we need to be more aggressive in building in a changing climate? Stephanie, do you want to, I know that's a big question, but just from your perspective, some thoughts?
Yes, probably. You know, luckily, a lot of these fires were just from the last, 20 years or so. A couple of people have looked at in the Southwest this sort of drastic change from pre-2000 to post-2000. So maybe we are already capturing some of that for the short, near-term future. It would be really great to take this research and maybe build in some future climate. So, Matt wasn't able to really talk about this, but he's hoping to test this out and see how it works. Is it all going to end up being in that very top right corner of the model? We'll see. We'll just have to see how it goes, but it would be really great to build in some of that future climate. And I think if we did this in the greater Southwest, that would be a lot more important. Whereas in the Grand Canyon, they're really actively managing and burning and reburning places again and again. And, they've got kind of that a little bit different ecosystem than the rest of the Southwest. So maybe in a couple of years, we'll have to redo it. We'll see.
Yeah, and it also seems like the framework is there, so some of the model inputs could change, and one, as you mentioned earlier, like you could put in different inputs for different locations. So there is some flexibility if the modeling, if the results and the sort of tools that you provided turn out to be useful for Matt and the rest of the team at the Grand Canyon. It seems like you could make some adjustments. So Jeff asked another question that, again, is a pretty big one, but Stephanie, you can take on as much or as little of it as you want. Do you bring other considerations into let burn fires, managed wildfires, such as jurisdictional boundaries? And do you look out, I think this you already answered maybe, do you look out multiple days, weeks in that decision?
So all of these fires burned within Grand Canyon. We did not use any fires that went out into the Forest Service land. So there weren't any jurisdictional boundaries to really deal with. And these fires were all mostly managed fires. So they were not suppression fires. These were allowed to let burn. So we didn't use any full suppression fires in this. And then as for looking out multiple days, we can look out about, for VPD, about, I think it was like 4 to 7 days. But beyond that, the weather forecast really isn't available, especially for wind and temperature. It just kind of cuts out about 7 days in advance.
And just to build on that, it seems like there are other tools that might be better at dealing with the jurisdictional boundaries, because obviously for managing wildfires, that's a crucial issue. And I'm wondering if tools like the potential operational delineations, pods, where those have been put in place on Forest Service, mainly Forest Service land at this point, those might be used in combination, like the tool you've designed, Stephanie, where, you know, for example, spread might give you a sense of when over the next few days you might run into a boundary, or whether that's jurisdictional or a pod boundary. So yeah, anyway, I think that's a good question. And I think we do have a lot of different tools out there. And so maybe a combination of them would get at it. Moving on to Catherine's question. She highlights it as a great presentation, and I'll concur with that. And then she asks if you could speak a little bit more, Stephanie, about the importance of vapor pressure deficit in your model. Is this a correlation based strictly on a daily VPD? Are there fire behavior trends related to seasonal VPD or long-term VPD trends preceding the fire?
So specifically for this research, we did day of. But, you know, my master's thesis was on vapor pressure deficits effects on fire severity in the Southwest. So we did look at some seasonal. So did the preceding, you know, did the annual VPD affect fire severity overall? Did the summer VPD affect fire severity overall? So it does have different influences. So if you have multiple days of high VPD, you're going to see the effects of that on the forest. And that kind of is captured in our, you know, these fires that have mostly happened during the main fire season at Grand Canyon. So it is in some ways capturing that. I create this for Grand Canyon that kind of gives you a overall of what VPD looks like on average at Grand Canyon for different months. So, you know, you can really see it's at its highest in June. And then on the bottom is the time of day. So 2 o'clock in the middle of June, you're going to see your highest vapor pressure deficit, and a lot less so in, you know, September, May, etc. So we provided this sort of information to Grand Canyon to help them determine when they should be starting to look out for these changes in vapor pressure deficit. And there's one for wind as well. So
that seems very useful. It strikes me that another tool that might help with some of that seasonal trends is the ERC information, the energy release component that Predictive Services provides, which I find fascinating because it gives you kind of that seasonal view, and you can kind of start to see, oh, wait a minute, we're heading into a phase where our ERCs are higher than, you know, the 10-year average or something. And it seems like that would be another piece of information managers could look at on a sort of seasonal scale, and then use your tool to kind of hone in a little more finely.
Yeah, absolutely. You know, we looked at ERC, didn't really pan out in this model, but it's of course an important tool that's well used in fire. So
Yeah. So let's see, I guess there aren't any questions right now in the chat window. Feel free, we've got a couple more minutes, so feel free to add a question. There are also few of us online that we could unmute. So if it's easier for somebody to unmute themselves and add in, you're welcome to do that. And I don't know if, looks like Matt has actually dropped off now. Hard to do a webinar from the woods. I really appreciate his effort there. But I know that Chris Marks is also on, and I don't know if Chris or anybody else from Grand Canyon wants to kind of weigh in on some of the management day-to-day, looking forward to using this tool, any initial efforts, that sort of thing. Oh, it looks like Matt may be back.
I know he was hoping to be on a fire out there testing the tool out during this, but yeah, I think we hope to maybe next year, you know, he's been starting to track this every day to see how it kind of pans out, and hopefully next year maybe we can do more of a co-presentation and see if it worked, or yeah, if we
Hey,
are
Stephanie.
seeing higher numbers. Oh, hi, Matt.
I don't know how long this will last if you
Okay.
can hear me, but
Yeah.
I just wanted to tag on to some of the questions there. And one of the most interesting indicators to me is vapor pressure deficit. And I just wanted to point out that within all the sample locations in Northern Arizona for our fire danger operating plan, so that's Mogollon Rim, Tusayan, North Kaibab, and the North Rim, our vapor pressure deficit was above the 90th percentile for almost all of June. And if you look at what was going on in June in Arizona, we had numerous type 1 fires, you know, Raphael fire, Telegraph fire, the Backbone fire. And I just really think that this is such a reliable indicator for large fire growth. And yeah, you know, I'm looking forward to using it, and I agree with everything you said. I've been trying to chime in the chat, and talk, but I think my connection's just not all that great here at this outpost we call the North Rim. So yeah, that's mostly it. I just wanted to tag on and get that one in.
Thanks so much for adding in, Matt, and because your connection seems good right at the moment, I'd be curious if you could expand a little bit more on Grand Canyon has a great history of good fire management and sort of the need for new tools, and the thinking about, well, obviously like any land management, there's a lot of challenges ahead of you and your team, and how you see this maybe helping to grab onto windows as they're available, because there aren't many, etc. Oh, you might, I don't know.
Right. Yeah. So, I mean, this is going to be a really important tool in our planning cycle. A lightning ignition, a natural ignition. Yeah. How am I doing now? Any luck?
Yeah. Right now you're good.
Okay. So this tool is going to be super important for our planning cycle. And so when we're creating a decision and going through that cycle, you know, this is going to be one element amongst quite a number of them to help us decide whether to move forward or not move forward with allowing a fire to move across the landscape or managing for resource benefit. And knowing those severity predictions is great when we start talking, you know, to our operations folks, and we start talking to our agency administrators, and when, you know, we want to make that prediction of what this fire might do.
Yeah, thank you, Matt. That's useful. We won't impose on you trying to call in from the outpost more. But I can imagine that for an agency administrator trying to make decisions, this helps get a little bit more concrete about what they might be signing on for.
Yeah, and Xander, if I still got you, you know, this could also affect immediate tactical decision making on the ground. You know, if we can predict a number of days out, we might be able to decide whether or not we need to prep a line and burn out to stop the fire, or you know, maybe we need to prepare and order more resources and bolster our capabilities if we think or expect this fire to make a large run, or maybe, you know, if we're out in the wilderness and this is part of the natural fire regime, it's just alerting us that this is about to happen, and we can be prepared for all of the additional consequences that come with fires making large runs. So.
Yeah, that's great. Thank you for adding that, Matt. Maybe we'll turn to one last question that Jeff just put in, kind of building on some of this conversation. And Jeff says in the chat window that Matt mentioned the National Fire Danger Rating System, and then the FOP, which I forget what the acronym is for. And Stephanie, does your matrix have good correlation to things like the burn index? Oh, thank you. Fire danger operating plan, spread component, or severe fire danger index. Do you have you worked on any kind of crosswalk?
You know, we did use burning index. That was an available spatial layer with Northwest Climate Toolbox. So, and it did come into at least one of the models. I don't know if I can remember right off the top of my head. So it was important in at least one or two of the models, but it wasn't consistent enough across all of them. So, you know, I don't know, some of these, you know, burning index, ERC, there's a lot going on behind the scenes, those equations to create these. So sometimes it can be kind of hard to deal with that in the model with these other, you know, if we have burning index and temperature and wind, you know, some of that's crossing each other out a little bit, potentially. So yeah, specifically, we didn't really focus on these fire danger metrics and really try to focus on the actual weather climate conditions, but yeah, they're still important.
Yeah, that's a great point about as you include a composite index in the model, you may be getting more than you bargained for, or multiple uses of temperature or something like that. So yeah. Well, let's see, pending sort of somebody typing in a question in the next minute or two, we'll move to wrap up. But again, if you want to unmute, you could do so, jump in right away and voice a question. But otherwise, I'll remind folks we have that WUI webinar on land use planning next month. I think it's towards the end of the month. And feel free to send other ideas for webinars. And Stephanie, I think I will try to take you up on the idea maybe a year or so, or 18 months from now, after there's some on the ground experience with this at Grand Canyon, because I think it would be really interesting to kind of hear the follow-up and how it was used. So great presentation, really nice to get clear step-by-step of a very complex model. So thank you.
And hey, Xander, I just wanted to say one thing. This is Andy. You know, it's because of Grand Canyon's really great data collection that they do and how they really manage their data sets that some of this was possible, especially when we're looking at the sort of large runs. You know, having that perimeter data daily and keeping that stuff so that it can be used for research is really, really helpful. And I know we have a lot of managers on the line, so I just wanted to throw that in.
It's a great point, Andy. I concur. Yeah, sometimes that data gets lost or it feels extra to collect it, but you can't build good tools like this without it. So good point. Thank you. Great. Well, so thank you again, Stephanie, and thanks to Matt for getting on from a difficult locale. And I appreciate everybody joining today, and hope to see you on a future webinar. So thanks to everybody.